A probability experiment is considered fair if all outcomes are equally likely. For example, flipping a coin is a fair experiment. This assumes that the coin is equally likely to land heads up or tails up. Such a coin is called a fair coin. A decision is fair if all the possible options have the same probability of being chosen. Probabilities can be very, very tricky. What seems like could be a fair game could be not a fair game. I mean, quite frankly, that's how casinos make their money, is they make things seem fair when, since they get to make the rules, they're actually in favor of the casino and not the player. So consider this example. Khalil, Amy, Diego, and Jenna are the officers of their school's video game club. They need to choose one club officer to attend a meeting of representatives from all the school's clubs. All 4 officers would like to attend the meeting. Khalil proposes they flip a coin 3 times, record the number of heads that appear, and use the table to determine who attends the meeting. Is Khalil's method result in a fair decision? Why or why not? So if it's a fair decision, that means that all the possible outcomes are equally likely to occur. So we can look at this using a tree diagram to see if this is a fair decision. So there's only 2 options. There's heads and tails. So when the coin is first flipped, the 2 options are it could wind up heads or it could wind up tails. When the coin is flipped again, there's 2 more options. It could wind up heads or tails after the first flip, or it could wind up heads or tails after the second flip. So you can see after the first 2 flips, the 2 options are heads, 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 tails, or tails, heads, tails, tails. It's actually 4 options. And then when the third coin is flipped, those options, and so each branch will also be heads, tails. So I'll quickly draw those in. And then this whole game to determine who's going to go to this, be a representative for the school's clubs, is based upon how many heads are flipped. So let's count how many heads are flipped. So on this set of branches, heads, 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 that means that there are 3 heads flipped. And then I'll do that for each of the branches. So 3 heads flipped there. In this end branch, that is 2 heads flipped. It went heads, heads, tails. On this branch, it's also 2 heads flipped. So it went heads, tails, heads. It followed this path. It went heads, tails, heads, just like that. And then this branch is heads, tails, tails. So that's only 1 heads that was flipped. And then the branch underneath that, barely squeezed it in, that's 2 heads. And then the branch under that was 1 head. And then we have a tails, tails, heads branch. That's 1 head. And then finally, the very bottom set of branches is tails, tails, tails. And that is 0 heads. So there are 8 possibilities, 8 ending branches. So each of these probabilities based upon how many heads are being flipped. So the first probability, the possibility that 3 heads are flipped. So the probability of 3 heads is 1 out of 8. It's 1 of the 8 ending branches. The probability of 2 heads, there are actually 3 ways to flip 2 heads. You got a way right here, here, and here. So there are 3 of those ways. So that probability would be 3/8. The probability of flipping 1 head would also be 3/8. You see there's 3 ones there, so that would be 3/8. And then the probability of flipping 0 heads. There's only 1 way to flip 0 heads. If that was if it was all tails, and so that would also be 1/8. So, is this a fair decision? Why or why not? You can see this is not a fair decision because those who got the option to flip 1 head or 2 heads, Amy and Diego, actually have a better probability of winning this game than those of Khalil and Jenna, who are picking 3 heads or 0 heads. And Khalil actually proposed this game, and he has one of the worst probabilities to win. So this is not a fair game because there's more likely that 2 heads or 1 head is flipped other than 0 heads or 3 heads. Now, is it possible to make a fair decision in this situation and explain? Yes, it is possible if you take into account the order in which the coins are flipped. So since there are 8 possibilities, you can actually assign 2 of each of the 8 possibilities to each of the 4 players. So we could say Khalil would actually be the winner if it followed these 2 branches. In other words, if all 3 heads are flipped, or if it went heads, heads, and then tails, Khalil will be the winner. If it followed these 2 branches, we could assign those to Amy. If it went heads, tails, heads, or heads, tails, tails, those would be assigned to Amy. These 2 branches we can assign to Diego. And these 2 branches we can assign to Jenna. So it's not impossible to set this up as a fair game, but you have to look at the order in which the heads and the tails are flipped, not just the total number of heads or tails at the end. Let's look at another one. Yoshio and Caitlin are playing a board game that uses 2 spinners. Each spinner has 3 equal sections that are numbered 1, 2, and 3. To determine who goes first in the game, they decide to spin both spinners. If the sum of the numbers shown is even, Yoshio goes first. If the sum is odd, then Caitlin goes first. Does this method result in a fair decision? Explain. If it is not fair, explain how they can use the 2 spinners to make a fair decision. So 2 spinners. Each spinner has a 1, 2, or 3. We're going to add the 2 spinner numbers together, very much like how you add 2 dice together to determine whether the sum is odd or even. So we can also explore this with a T-chart. Excuse me, not a T-chart, a tree chart, tree diagram. So there's 3 options for the first spinner. You can have 1, 2, or 3 for the first spinner, and then each of these branches are going to branch off into 3 more, with the second spinner also being a 1, 2, or 3. So my final outcomes are going to be when I add the 2 spinners together. So the first branch, this is a 1 plus 1 branch, which is equal to 2, and that is an even number. This branch is 1 plus 2, which is 3, and that is an odd number. This branch is 1 plus 3, that equals 4. That is an even number. And so on. So I got 2 plus 1, which is 3, that is odd. And then 2 plus 2 is 4, that is even. 2 plus 3 is 5, that is odd. 3 plus 1 is 4, that is even. 3 plus 2 is 5, that is odd. 3 plus 3 equals 6, and that is even. So, how many evens and how many odds and how many total possibilities do we have? We have 9 inning branches, so everything's going to be based upon 9 possibilities. There are 5 evens, 5 even sums, 1, 2, 3, 4, 5, right through there. So that means the probability of even in this case is 5/9, and the probability of odd, there are 4 odd sums, is 4/9. So the probabilities are not the same, so this is not a fair game because whoever has the even possibility, which appears to be Yoshio, has a better chance of getting to go first. So how can they use the 2 spinners to make a fair decision? They really should just throw out one of the even possibilities. For example, they could decide to make a special rule that states that if the sum is 6, which is one of the even possibilities, we could just say we're going to make that a do-over. Means we'll respin both of the spinners and then make that a do-over, and that means that both the possibilities for even going first and possibilities of odd going first would be 4/9. If the sum is 6, it will be a do-over. The owner of a candle making business wants to choose among 3 suppliers of wax. All 3 suppliers offer the same wax at the same price. The owner has a random number app on her phone that chooses a random whole number from 1 to 1,000 inclusive. That means including 1 and 1,000. How can she use the app to make a fair decision? So we got 3 suppliers. We'll just call them supplier number 1, supplier number 2, and supplier number 3. So what we can do is assign certain numbers to each of the 3 suppliers. We're going to choose from numbers 1 to 1,000. So since there are 3 suppliers, we want to make each of the suppliers equally likely to get a to actually win this. We could just divide 1,000 by the 3 suppliers. That gives us 333.3 repeating. So I'm going to ignore the remainder portion of it, or the decimal portion of it. That means I can put 333 whole numbers 3 times into 1,000. So for supplier number 1, I'm going to assign the numbers 1 through 333. For supplier 2, we will assign numbers 334 through 666. And for supplier 3, we can assign numbers 667 through 999. That still leaves 1,000. So if 1,000 is chosen, we'll just call that a do-over. So if some rare case that the random number generator chooses 1,000, you do it over again and then hope that numbers 1 through 999 are chosen so we can choose one of these suppliers. Similar situation to number 2. This time we have the owner of a candle making business who needs to choose among 7 suppliers of wicks. All of these suppliers offer the same wicks at the same price. How can the owner use the same number app, random number app, to make a fair decision? So we've got 7 suppliers. This time I'll call them A, B, C, D, E, F, and G. That's 7 different letters. I'll start out by dividing 1,000, this time by 7. And when you take 1,000 by 7, you get 142, about 0.85. It's because you have a remainder of 6. That's where that 0.85 comes from. So each one of these suppliers will be assigned 142 different numbers. So we'll start out by assigning A, numbers 1 through 142. We can assign B 143 through, that would be 284. We can assign a supplier C 285, and let's see, what's 142 times 3? That would be 426. Supplier D would be 427, and 142 times 4, that would be 568. Supplier E, that would be 569, and then its end number would be whatever 142 times 5 is, that would be 710. Supplier F, that would be from a 711 to 852, that is 142 times 6. And then supplier G would go from 853 all the way to 142 times 7. 142 times 7 would be 994. Then we do have some numbers left over. We have numbers 995 through 1,000, and that will be our do-over. So if 995 or through 1,000 are chosen, we will hit enter on the random number app generator again and see if it comes up with a number from 1 through 994.